Hmm.
Speaking of bull in a china shop, we talked a lot last week about DeepSeek and its disruptive elements in terms of upsetting the established sort of AI space. Um, and I wanted to revisit a little bit today because after the hype settled, I think we got a little bit more introspective articles and analysis that really dove deeper into what really happened and what this represented. And it actually changed my mind a little bit about what this represented. And so we won't go through all of them. There's a total of four articles that I identified. One is actually a LinkedIn article by my new boss, Pratik Kathpal, talking. And this was actually one of the more um, genuinely one of the more interesting articles because it dove really deep into the fact that one of the things that DeepSeek did was ditching CUDA, which is an NVIDIA's
Hmm.
sort of framework for PTX, which is the sort of the assembly level language to actually reprogram the chips. And that sort of message was hit on in a number of other articles, one by VentureBeat that talked about how they're focused on reinforcement learning. Um, the one of the co-founders at Anthropic had a slightly critical take looking at this and really started making the case that, hey, this was in fact a pretty real thing, and it was driven by the fact that we constrained them, but it's also something that when you look at it and abstract it away, again, as we talked about, really wasn't that unanticipated. The big surprise would have came out of China, not from Anthropic or OpenAI. And then the last one of the people that we are huge fans of, Ben Thompson, who has the Stratechery, I can never say the dang name right, did a whole FAQ on it, which dove really deep into all the stuff. And one of the things was this idea of the distillation, as well as that the real innovation was in V3, which preceded the release of R1, and sort of dove into it. So, I don't know if you had a chance to get through all of them, but the big takeaway was that there was some real innovation. It was really driven by the fact that these constraints did in fact work. And that was sort of the old saying, necessity is the mother of innovation, that it forced them to become much more efficient in how they approached it, which led to these breakthroughs. And that is truly notable. But on the other hand, it's still the fundamental economics, the fundamental march here is that we are still on the sort of pathway to the fact that this is probably good for the entire market, and maybe not as unexpected as all the hype sort of implied. So I know that's a whole lot, but I'm just curious what your take on reading through all those articles were.
Yeah, there's three things that really got my attention. That first, as you said before, the use of PTX as lower level language to help support model development was really interesting because we have gotten into a mindset over the past 10 to 15 years that we can just code our way out of any situation, just add more code. If we look at enterprise applications, they're notoriously spaghetti code, unfriendly, and disgusting just from a proofreading and editing perspective. And the idea that you could have more elegant and more focused code to get around the storage issues of not having H800s in your data center. I think that's a great step forward for saying, hey, there's more than one way to get to these super complex models. So I'm excited about that because it means you have to be skilled at developing again, and that's a differentiator potentially again for you to be able to get around the multi-billion-dollar budgets that OpenAI has to be able to do something else. And we also saw that the $6 million number was a little bit overplayed since that was just the final training number for the V3 model. The second thing that I thought was really interesting was that this improvement in training reflects a distillation of models. So the head start that these companies had in building these foundation models is gone now, because now that we can distill from these large models, that gap, that perceived moat that existed the past couple of years, it's the end of that. Honestly, I think that's what the easy takeaway there. And one of the little nuances that I thought was really interesting was how they were able to improve these models by moving from kind of floating point 16 or 32 bit to FP8, 8-bit parameter. basically shrinking all the parameters and getting rid of a little bit of detail at the edges, at the what they call the mantissa or the fraction, like the 0.123, 0.895, instead of having an 8-bit or whatever, they might have shrunk that down to 4 bits. And like little things like that lead to big picture efficiencies, both from a training and a deployment perspective. And we don't have to always make things more and more complicated at every single level to get to these high performing models at the end of the day. The fact that DeepSeek was able to show that we can still tweak all these little bits of the pieces of the puzzle to get to the high level model results, I think is an important finding, because it means that we can actually still optimize a whole lot of things that are in the devil in the details.
Yeah, so I'm gonna putting my CIO lens on this. What are my big takeaways? Well, to me, the big takeaway is that we are still wild, wild west. There's going to be a massive continuing battle, and it is a race to the bottom. We're not investment analysts. We're not looking at it from that perspective. But while I don't think this represents an existential threat to any of the players, Stratechery identified that Google is probably the big loser here, and I would agree with that assessment. But generally speaking, we're on a march to AI being infused into everything, and we're at the very early stages of all of this. There's still nothing but upside and runway for pretty much everybody. I think, though, the big takeaway, and this affects both the CIO as well as anyone who's in the AI space that isn't one of these big giant companies, is that what this says is you can sort of count on the fact that the ongoing cost of both model development and inference will continue to drop. So this is a really positive sign from an efficiency standpoint. That the big barrier that we were all sort of keeping our eyes on was the power consumption, the ability to build data centers fast enough, all of that stuff, and this hints to the fact that it's not even so much that these particular innovations, but the fact that these innovations exist, the possibility for these innovations exists. We don't just have to keep throwing more and more compute at this to make it work. And so those are really positive signs. And that means if I'm a CIO, those are some of the risk factors that this sort of suddenly started to mitigate a bit. It means I can start moving forward with some of these investments with some confidence that those prices are going to continue to drop, and it's going to be much more manageable to deliver this. Because frankly, I think, up until this happened, a lot of us were sort of scratching our head. It's like, are we ever going to get to this point? Because AI didn't operate at like the way cloud did, where increased usage actually decreased your cost.
Mm-hmm.
And this is the first side of real sign that maybe it will in fact do that. And if that's true, then suddenly everything changes. So I think there's some really positive signs around it. And it also means model independence is your friend. You want to be developing approaches that allow you to pick the best model for your use case or at the moment, because we're going to see a lot of this back and forth.
Yep, absolutely.